product with the technology.
It's an education challenge.
A regenerative suspension.
There will be a growing demand for industrial photovoltaics.
Pumped hydro.
Innovation in the financing space.
The high-speed train is in all our interests.
All political lines.
Australia is a solar paradise.
The market is moving much faster than that.
You've got something that's transformational.
Solar window in a can.
Beyond Zero, global.
Hello and welcome to another edition of the Beyond Zero show. We're coming to you from the studios of 3CR Melbourne, syndicated around Australia on the Community Radio Network and podcast on the internet at bze.org.au. You can also follow us on Twitter at BZE Tech Show. My name is Kay Wenigal and I'm joined today by my co-host Natalie Bucknell and Michael Steindl.
Hi Kay, hi listeners.
Hi Kay and Nat and everyone.
Today we're going to be talking to Jonathan Knight, CEO of Uprise Energy, an energy startup specialising in portable renewable energy. Welcome Jonathan, thanks for joining us.
Hi there, good to be here.
Sounds like a very exciting product you've got here. But Jonathan, you haven't always been in the energy game, I understand. Can you tell us about the path from maritime to energy?
Yeah, well, I'm co-founded in Uprise Energy with my dad, John Knight, and my dad founded a custom yacht building company a little bit before I was born. So that was the world I grew up in, building one-off custom yachts and working in a big marine repair facility. And it was because of that background and expertise with composites, fiberglass mostly, that led the large wind companies to our company to help them resolve some serial failures with their big wind turbine blades. And so what started as a blade repair business evolved into new blade manufacturing. We realized that it was more efficient to service wind turbine blades on site. So we developed a field services division where we grew to about 400 employees that worked on large wind farms all around the world. And then with the U.S. Department of Energy, we collaborated on a new class of wind turbine blade. It was called the Star Blade, which happened to be that was an acronym for Sweep, Twist, Adaptive Rotor, which...
Sweep, twist, adaptive
yeah.
rotor.
Yeah, so unlike a standard wind turbine blade that is straight, this had kind of a banana shape to it, so that was the sweep. And then under wind pressure, it would twist a little bit, and so it would dynamically change the angle of attack of the blade, maintaining a really high efficiency for the blade. And it also dramatically reduced the shock load on the drivetrain, because on traditional wind turbines, when a straight blade passes in front of the mast of the wind turbine, it creates a shadowing effect, which shocks the drivetrain. And because of the sweep in the blade would have a tendency to walk in and walk out, which dramatically reduced the shock. That blade achieved a 52% coefficient of power, which I believe is still to this day the #1 performing wind turbine blade ever built.
That's amazing.
Fantastic.
52%.
I never thought of that issue of the stand affecting the performance of the blade.
Yeah, it's a big issue.
So what would normal commercial scale wind generators, what sort of efficiency do they have?
Well, at the large utility scale, the really good ones are in the mid 40% range. The product that we're bringing to market is at a smaller scale, a 10 kilowatt unit, and with the competition in that range is maybe 25% at best.
Okay. Now I was going to ask you about what Uprise Energy, why you called it Uprise Energy, but you've just virtually explained that, I think.
Well, maybe. So the name Uprise was something that my wife came up with, but what we are bringing to market is it's a portable wind turbine that operates autonomously, and it ships in a standard shipping container. You can tow it with an ordinary vehicle, and when you arrive on site, one person can set the whole machine up in 1 hour's time without site improvements or heavy equipment or any specialty training for that matter. And the machine has been designed to operate especially well in the lower wind speeds that are commonly found around the world. And so the machine does have what we call it the lay down feature, which refers to the way that the mast will lay itself down, and obviously it will uprise and move into its upright and operational position.
It's an amazing video you've got on your website.
Yeah, I was just going to say to listeners, you must do yourself the justice of going and having a look at that. Excuse me, that video. It's about 3.5 minutes on Vimeo. Just search Uprise Energy, and it is probably the coolest piece of engineering I've ever seen in my life.
It's certainly very fun to see.
So the idea of portable wind energy, Jonathan, it's intriguing because it runs counter to some of the things that we hear about wind. To successfully generate energy from wind turbine, you need careful planning about location, incorporating at least 12 months of data on wind patterns. Then you need laminar flow, which necessitates an area with very few disruptions in the landscape and high elevation. How do you overcome these limitations? You referred to having a more efficient unit.
Yeah, well, you covered a lot of ground there in that question. So we, coming from the large utility scale wind energy background, we were acutely aware of the many challenges that go into setting up a traditional wind turbine. And when we started the project, the goal was to make a machine that could be shipped anywhere in the world easily. And then when it arrived on site, it could be set up and operated by a local workforce, overcoming the many constraints that the traditional wind turbines deal with. And so one of the big challenges of wind is, if you want to set up a wind turbine, from the time that you say, I want it, to the time that it's actually up and operational, it's probably a 2-year window. And so you go through the wind study to begin with. Well, first you need to acquire the property. And then you go through a long wind study to make sure that the site that you've picked is going to be appropriate for wind energy. And because once you're there, you're pretty much locked into that location. And there's a lot of site improvements that go along with setting up a wind turbine, big heavy equipment that's involved. And we wanted to see if we could avoid all of that and really come up with a machine that would be an alternative to diesel generation for the most part, for the grid's edge and beyond. So we started by designing a machine that would be easily shipped. So it was a containerized solution. And then we wanted it to be set up easily. So unlike the traditional wind turbine, where you might go through a 12 or 18 month wind study to make sure you've picked a good location, wheel our machine in, set it up in an hour. If it works good in the spot that you've chosen, great. If you think it might work better over, on the other side of the barn, move it over there. And you've only invested a couple hours time. So that was a big difference. And then, but knowing that we were going to go after that distributed generation, and there was a practical limitation to how big we could make the machine, being that it was portable, we knew that we had to do some really special stuff in order to get it to perform in the lower wind speeds that are commonly found around the world. If we're going to serve the power direct to the customer, because wind turbines, they want heavy wind to make good power, and that's pretty much what all of them are going for. But so we focused in on a commonly found wind speeds, and we really optimized around a 4.5 meter per second speed, which back in the US that's 10 miles an hour, or in kilometers that would be 16 kilometers an hour, as being the point that we wanted to start making good reliable power, and which also happens to be the global average wind speed. And so that's what we did. We optimized around that lower wind speed, and we have a feature that takes advantage of the variability in wind. It's probably the feature that I'm personally most proud of in the whole development process here. We call it dancing with the wind. And so what that refers to is the way that the rotor on our machine it'll speed up and it'll slow down to match the variability and the changes in the wind speed, maintaining the really high efficiency that our blades have throughout those changes of wind speed. And that's important because the energy in wind it grows exponentially at the cube relationship of the wind speed. So, meaning just a small increase in speed equals a pretty significant increase in kinetic energy. And so, again, with our philosophy of maximizing the energy density of our portable platform, we wanted to take advantage of that exponential power that's available in wind gusts. And so that's what we did. And so unlike, traditional wind turbines that they try and spin the rotor at one steady speed, and again, to use kind of another catchphrase, they fight with Mother Nature, where we choose to dance with her. And so that's something that we did that was unique. We and one of the areas that we've kind of cracked the code, so to speak, is we figured out how to allow the rotor to spin at a variable speed to match that wind. And
So is that the essence of one of the highlights you write about on your website of the energy conversion system, or is that more than that? And how do you do that variability, or is that a trade secret?
Well, it was an evolution of how we came up with that. And so in the beginning, traditional wind turbines are spinning generators that like to be spun at one steady speed. And so they don't want to spin too fast or too slow to avoid leading or lagging power factors. Mm-hmm. And so we came up with a hydraulic solution. It was a reverse ratio hydrostatic drive system that would allow us to spin the rotor at a variable speed while spinning the generator at a constant speed. But through the development process, we realized that we could accomplish the same thing with electronics. And so, yeah, this does kind of get into some of our proprietary secret sauce here. But through our own electronic solution and a permanent magnet alternator, we are managing the rotor RPM. Actually, we're making checks about 100 times a second to make sure that we have that perfect relationship between rotor speed and wind speed.
So you're no longer using a hydraulic system, it's all done in Magic Electronics.
That's right.
And you did talk, your blades are something special. Is that the star stuff that we talked about? Is there anything additional to tell us about there with the advances you made in your blades?
Well, the blade design process, we engaged the #1 blade designer in the world to design our blades. And again, we targeted that 4.5 meter per second wind as being the real sweet spot that we wanted to shoot for. And the blade design process, they modeled over 2 million unique blade shapes over nearly a month's time before we said that's the design that we want to use for our blade. And I'll also say, though, that to make a very powerful blade, you end up with a long and skinny blade, which poses some manufacturing challenges. And so that's something that I'm also pretty proud of, is the way that we've been able to develop some advanced manufacturing techniques to create the requisite stiffness out of the blade in this difficult form.
So what sort of materials are there in the blade?
So it's a carbon fiber construction with a closed cell foam core.
Mm-hmm. Okay. And what sort of efficiencies do you get from the lowest wind speed to the highest? So I think you said it's 4.5 meters a second to 100 kilometers a second, 100 kilometer an hour winds. Is that?
Well, yeah. So, the nameplate rating on our wind turbine is 10 kilowatts, and it makes that full rated output at about 9 meters per second. At 4.5 meters per second, we're making right about 2 kW, and the blades themselves, the ones that we're using, have a 48% coefficient of power, which is roughly double that of the leading technology in that size range. And then when you add the dancing with the wind feature that takes advantage of the gust energy, it's going to vary depending on the wind regime, but in a typical wind environment, you could expect to see another 2x in the performance over a conventional wind turbine. So it achieves that high efficiency pretty quickly in the power curve, and it maintains that. And then the machine will operate right up until about 100 kilowatts. 100 kilometers an hour.
And then what?
And then what? Yeah, and then the machine will autonomously lay itself down to get out of that wind, so it can protect itself.
Clever.
So yeah, and that's kind of an interesting part of it, because traditional wind turbines, they're all designed to withstand that storm condition, and in doing so, their performance is compromised. So on our machine, with the confidence of knowing that our machine would just simply lay down and get itself out of that storm condition, we were able to maximize the performance from every angle.
Do you mean you're making the conventional ones strong enough to withstand that? They compromise the performance.
Yeah, that's right.
So so far it sounds like the magic bullet for everything. There must be some limitations, I guess, on where it can operate or the conditions it can be in. What would you say those are?
Well, if you don't have wind. And not everywhere does have wind.
Our federal government will love you. They're always saying when the sun doesn't shine and the wind doesn't blow. That's their argument against renewables.
But in terms of, if the wind direction is changing quite a bit, if you're in an environment where it's quite turbulent, can it accommodate that, or would you avoid that?
No, the machine, it has a LiDAR system on board, and so it's constantly monitoring wind patterns, and it's making real-time decisions as to which direction to face the rotor so that it is pointing towards the wind. So a multi-directional wind is not an issue, and actually with the Dancing with the Wind feature, the more the variability, the better that we're going to perform. We
perhaps haven't brought out to the listeners enough how portable this device is. You did mention it in passing that it fits in a 40-foot container or a 20-foot one for your 10 kilowatt unit.
Yeah.
But it's absolutely magnificent the way you can just take it out to a site, take it out of the box, and it erects itself, except for someone just screwing the blades on. So, what are the applications for this? Obvious things spring to mind, like military, when they're going out to a new site, or an emergency, say a natural disaster or something. But what about Nats Farm or outback communities in Australia, mining town? Are they prime applications, or where are you targeting?
Yeah, the applications for the machine are numerous. The reality is the machine will make power for less than utility power rates. So if you've got the room to set the machine up and you've got a nominal amount of wind, it makes sense to run one of these machines. But where I think we have our real competitive advantage is at the grid's edge and beyond, and for disaster relief situations like you mentioned. And what I will commonly say is that I think that the closest competition for the machine is going to be the diesel generator because of the portability of it. And so right now, the majority of the traction that we have for the technology is in island nations, which disconnected from the grid, typically good trade winds, and most of them are currently running on diesel generators.
You've just tuned in. We're talking to Jonathan Knight about portable wind turbines. So, talking about those applications, have you actually got any of these units in operation at the moment, or is this still?
Yeah, we're in a development process right now. We have built a prototype at our factory in San Diego, California. We've towed it on California highways, set it up in the foothills of San Diego. Basically,
Nice windy place.
Well, occasionally. Not quite Australia wind, but
Oh, okay.
and yeah, so we basically proved out the technology, proved out our power curve, and as we speak, we've got a team back in San Diego that's building our beta version, which is the one that we intend to take to market, and so that will be up and testing here in a couple of months, and we hope to be commercialized at the beginning of 2019.
So you had that prototype, I think, in 2012. Was that when it first came out?
No, that was around the time that we started the the conversation around this business.
When did the prototype come out?
The prototype, we tested our prototype, well, let's see, it was probably about 14 months ago now.
Okay.
Yeah.
So I was going to be rude and say, what have you been doing since then? Because I thought that video was older. So pricing on this?
Pricing on this, well, what we focus on is the really the cost per kilowatt hour. We think that's what will compare our technology to others that are out there. And so in that 4.5 to 9 meter per second wind, or 10 to 20 miles an hour, we expect to make power in the 10 to 20 cent per kilowatt hour range, US numbers. But the equipment cost hasn't been finalized yet, but we expect to be able to sell these to our distribution partners at $80,000 per unit.
So you've got two different types of units. You've got the 10 kilowatt unit and
The 50 kilowatt.
50 kilowatt. Which one?
The prototype was the 50 kilowatt, is that correct?
Well, no, the prototype was our 10 kilowatt unit. The video on our website that you referenced earlier was that was around our 50 kilowatt. So the 50 kilowatt fits in a 40-foot container, and our 10 kilowatt fits in a 20-foot container.
And the transporting these, it is as simple as towing this container. Is that all it is?
Well, the containers are a very standardized method of shipping. So the trailer fits inside of the container. When the container arrives on the port, you can hook up to the trailer with a ordinary pickup truck and tow it down the road like you might a ski boat, and tow it to your site. And when you arrive on site, again, one person can set the whole thing up in 1 hour's time. Pretty straightforward setup procedure.
So what sort of towing weight are we talking here?
About 3,000 kilos.
Okay. Yeah, so
Which brings us back to the storage. You do mention on the website that you can provide storage with your system. Is that included in the base unit you're talking about, this $80,000 unit and 3,000 kilos?
So the wind turbine, it could be hooked up to a utility power grid, to a microgrid, or it could be islanded in a standalone configuration. So if you're hooked up to a utility grid, you're going to make all the power you can and dump all that power right into the grid. And in that case, energy storage is not going to be important. And so
Agreed, yeah.
So at that base price, it will come with just enough battery storage in order to stand the machine up and go through the setup procedure. In the islanded configuration, you're probably going to want to put as much energy storage in the machine as you can, and so you'll probably fill out the belly of the trailer with as much batteries or flywheel or other forms of energy storage as possible. And to that end, if you just simply use traditional lead acid batteries, there's room for a little over 100 kilowatt hours of battery storage, and that number goes up quite significantly when you start getting into the more exotic lithium ions and those sorts of battery types.
Jonathan, you've designed these really clever blades. Why don't people use that on existing, commercial scale wind farms? Those obviously they sound like they're far more efficient.
Well, that's a good question. You making a powerful blade is only one part of the equation. Controlling that power is maybe the bigger challenge, and that is one of the features that our Dancing with the Wind system addresses. Is we are able to control that power. Because if you can't control it, because the energy in wind grows so quickly, one of these wind turbines will have a tendency to either want to beat itself up or maybe fly away like a helicopter.
But you'd obviously have fail-safe mechanisms in place.
Yeah, absolutely, we do. So that's built into the programming. So we have a maximum RPM that we control within. If our electronics are unable to control to that RPM, then we have a disc brake system that takes over beyond that. and it will it'll go through its own autonomous shutdown procedure.
So just quickly following that thought of Kay's question though, is there the potential for major fixed turbines to come to you and adapt your technology, and have you had any interest on that, or is it really applicable to these smaller turbines?
Well, yes, so the dancing with the wind is a part of our patent protection, and so that is a possible opportunity for us is to license that technology to other OEMs. Those aren't conversations that we're having, but it is something that could potentially come down the road. As we talked about a little bit earlier, because our hub height is a little bit lower than traditional wind turbines, we have more variability in the wind, and so that feature is going to have more benefit than the great big giant wind turbines that are 100 meters tall and operating in steadier wind. But all wind is variable, and yes, the features that we've developed here would have benefit to all wind turbines around.
So talking about the height, when you get the unit out of the container and it installs itself, goes upright, then it actually extends the mast, doesn't it? So what sort of height can you extend to?
So on our 10 kilowatt machine, the top of the blade is 20 meters tall. The rotor has a 7-meter rotor diameter, and the outriggers make about a 10 meter radius. 10 meter diameter footprint.
We've only got a minute, so just quickly, Jonathan, you're the CEO. This company is San Diego based. We're lucky enough to have you here in the studio today. This is part of the Startup Bootcamp. What is Startup Bootcamp? Who's running it? What's the program consist of?
Startup Bootcamp is an international accelerator program that have 20 some odd accelerators around the world that all specialize in different industry niches. The one here in Australia is an energy focused, and it is being run by Trevor Townsend and Richard Selm, a couple of really great guys who went around the world interviewing energy companies to ultimately select the top 10 that they wanted to invite to Australia for a 3-month accelerator program. And that's what we're doing here.
Yeah, so like our interview last week, you're one of those 10 out of hundreds and hundreds, or thousands actually, that were interviewed for this program.
Yeah, I think there was a little over 2,000 that began the application process, and which ultimately got whittled down to 10.
Well, I think we're just about out of time, Jonathan. It's been very exciting. I'm really looking forward to seeing the product get underway and see how it really performs, and seeing them over here. And listeners can find out on your website, Uprise Energy, more information about the product.
Yep, that's right. UpriseEnergy.com. We do have a website up now, but I will put out there that we're looking to launch our revised website here in the next week or two. And of course, we're on all the major social media channels. Seem to be most active on Twitter, but Uprise Energy is the handle across them all.
Jonathan even tweeted our show this morning, I know, or yesterday.
Yeah. Thanks again, Jonathan. We've been speaking to Jonathan Knight about his wind turbine energy business, Uprise Energy. The Beyond Zero show is brought to you by the climate change solutions think tank Beyond Zero Emissions, and is recorded in the studios of 3CR Melbourne and syndicated around Australia on the Community Radio Network. If you want to listen to this show or any of the others we've done, you can go to bze.org.au and click on podcasts.